Topic for today is special angles and radians. We need a couple of reminders first. One reminder, a radian is approximately 57.3 degrees. That will not be too useful to us for today. The other reminder is pi radians. Pi, just think of it as a number. It's about 3.14. Pi radians is exactly 180 degrees. That will be very useful. Reminder number two, the coordinates for special angles, if we're on a circle with a radius of 1, 30-degree type angles are going to have coordinates of 1/2 and root 3 over 2. 45-degree type angles are going to have coordinates of root 2 over 2. Reminder number three, we have been able to get trig ratios for special angles without too much trouble. The 45-degree types are right here in the middle of the arcs, and the 30-degree types are a little to the left or a little to the right. And again, if you notice, one of the coordinates ends up being a half, right? If the radius is 1, then this is about 0.5 right here. So 30-degree types are a little to the left and a little to the right of the 45-degree types. So if we wanted to find sine of 150, this is 30 degrees, 60 degrees, 90, right? I'm being kind of tedious about this. 120, 150, and there it is. The sine ratio is the y coordinate, and if I look over there, the y coordinate is clearly 1/2. Cosine of 225, here's 45 degrees, 90 degrees. This next one would be 135 here, 180, and then 225 is right here. I realize there's quicker ways to do this, but I'm sort of going by 45s. Here's the first 45, the second 45, the third 45 type, the fourth, and the fifth. And 225 is right there. Coordinates are root 2 over 2. The x-coordinate for cosine is clearly negative. And we got it. All right. We're going to do the same sort of thing that we just did, except with radians instead. So first of all, a 30-degree type, how many radians is that? Well, 180 degrees is pi radians. And if we divide that by 6, we'd get 30 degrees. So 180 over 6 is 30 degrees, so that's the same thing as pi over 6 radians. And for 45 degrees, well, 180 over 4 is 45 degrees, so pi over 4 would be the radian measure for 45 degrees. So our special angles, and this is a thing to memorize here, our special angles are in radians are going to be some version of pi over 6 radians or some version of pi over 4 radians. To mark each of these angles on the circle, it's really just going to be about counting. So here's pi over 4. That's the same thing as pi over 4 radians, same as 45 degrees. Here's 2 pi over 4, right? Just double that. Triple it. 1 pi over 4, 2 pi over 4, 3 pi over 4 would be right here. 4 pi over 4 would be right here. 5 pi over 4 would be right here, and so forth. Let's think about the 30-degree types. So I should use a different color. Here's pi over 6 or 30 degrees. Here's twice that, 2 pi over 6 or 60 degrees. Here's 3 times that, 3 pi over 6. Notice 3 pi over 6 is the same as 2 pi over 4. You might think of this as kind of a pi over 4 type of angle. You might think of it as a pi over 6 type of angle, depends on what you're doing. Keep going. This will be 4 pi over 6, 5 pi over 6, 6 pi over 6, and so forth. So if we mark off by 30 degrees, just count them off. Pi over 6, 130 degrees, 2 pi over 6, 230 degrees, 3 pi over 6, and so forth. Where's pi over 4? Here. Where's 3 pi over 4? 1, 2, 3. Here. Where's 5 pi over 4? 1, 2, 3, 4, 5. Right here. Where's pi over 6? Here. 5 pi over 6? 1, 2, 3, 4, 5. It's right there. 7 pi over 6? 1, 2, 3, 4, 5, 6. 7 pi over 6 would be right there. Okay. I'm going to redo all of this now. Let's put all the angles together on one diagram. This is pi over 4 right here. 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7 pi over 4. Pi over 3, a 30-degree type is, or I'm sorry, pi over 6, 30-degree type is right here. And there's another one over there. So 1 pi over 6, 2 pi over 6. This counts for both again at the top. This is 3 pi over 6. It's also 2 pi over 4. Boom, boom. So the red ones are my pi over 6 or 30-degree types. All right. Now when you're finding these, pi over 4, it's already marked. It's right there. 3 pi over 4. We're ignoring the red ones. Start at the start. 1 pi over 4, 2 pi over 4, 3 pi over 4. It's right there. 5 pi over 4. Start at the start. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. It's right there. It's just pi over 4 5 times. Pi over 6. It's right here. 5 pi over 6. It's pi over 6 5 times. 1 pi over 6. 2 of those. 3 of those. 4 of those. 5 of those. 5 pi over 6 is right here. 7 pi over 6. You can count to 7. 1, 2, 3, 4, 5, 6, 7. It's pi over 6 7 times. There it is. If I'm going by pi over 6, I use the red ones. If I'm going by pi over 6, I use the black ones. Some show up for both, right? This one's up at the top, and on this side show up for both. Little trick. 4 pi over 3, think of that as 8 pi over 6. So it's pi over 6 8 times. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 pi over 6. 3 pi over 2, you could think of that as 6 pi over 4 if you like. You could also think of that as, let's see, if we wanted to do sixths, you could think of it as 9 pi over 6. Both those will get you in the same spot. All right, I've got my diagram drawn. If I'm dealing with a 30-degree angle, the coordinates are going to be root 1/2 or root 3 over 2. If it's 45-degree type or pi over 4 type, it's going to be root 2 over 2. Let's do this quickly. Pi over 4. So question number 1 is going to involve that right there. Sine is the y coordinate. It's going to be root 2 over 2. 7 pi over 6. 1, 2, 3, 4, 5, 6, 7. Question number 2 is going to involve that point right there. Sine is the y coordinate. I think you can see the y coordinate is going to be the negative 1/2 for that. And I am done with question number 2. Question number 3, pi over 6. Pi over 6 is right here, so darn it. So question number 3 will involve that point right there. The y coordinate is the 1/2. The x coordinate is the root 3 over 2. The 2's divide out. I'm left with 1 over root 3. If I want to be fancy and rationalize that, I'll multiply by root 3 over 3, and I'll get a final answer of root 3 over 3 would be my final answer. For number 4, pi, I could think of that as 6 pi over 6 if I want, or I could just memorize that pi is 180 degrees, but question number 4 is going to involve that point right there. Cosine is the x-coordinate. It's going to be -1 for my final answer. 3 pi over 4. 3 pi over 4 is going to be this spot right here. I'm just counting by pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4. It's right there. Tan is the y-coordinate over the x-coordinate. It's a 45-degree type, so they're both root 2 over 2. Y-coordinate's positive, x-coordinate's negative. Something divided by itself, right? Something divided by itself is 1, and there's a negative there, so it's -1 is my final answer. Pi over 3, pi over 3 is like 2 pi over 6. So for question number 6, I'm dealing with that spot right there, right? Count the pi over 6's. Those are the red dots. Pi over 6, 2 pi over 6 gets you right there. Cosine is the x-coordinate. I think if you look at that, you can see the y-coordinate is the root 3 over 2 type. The x-coordinate is the 1/2. So 1/2, final answer, and I'm done. And that's all there is to it once you get the hang of just counting to figure out where a special angle is when it's the units are given in radians.